That's 2.
This is man's best friend.
How many was that? 8. And that's 3 times 1.
Dogs and their owners depend on one another. Those two have a relationship. The dog gets food and shelter from its owner, and in response, the owner receives affection. There's also a mathematical relationship at play called a function, which we can see in this game of fetch. A function is a relationship between two numbers when the value of one variable determines the value of the other. In this one-to-one relationship, there's only one value of the second variable for each value of the first. When the dog owner throws a toy and the pup goes out and brings it back to the owner, there's a unique relationship between the throw's distance and the distance the dog goes to get the toy. That makes it a function. If the owner throws it 30 feet, then the dog travels 60 feet out and back to get it. If the throw goes 40 feet, then the dog goes 80 feet, and so on. We can express the same function in several ways, such as tables, graphs, and equations. Let's fetch more functions. Ever heard the saying, as good as gold? Gold has been highly valued for ages. In fact, some monetary systems were even backed by gold. That means money's worth was tied to the amount and value of gold available to exchange for it. In fact, gold's still a prized possession as jewelry or an investment. Today, gold's value, or price, depends upon its weight and purity. This is a function. A function is the relationship between numbers in which one uniquely depends upon one or more others to determine its value. For a given purity of gold, the value at any given time depends on its weight. We can represent this function for gold in a table. In this case, the purest gold is called 24 carats and is weighed in troy ounces. The table shows how the market price for 24 karat gold depends upon its weight. It shows that 24 karat gold's price is $466 per troy ounce. The more there is, the greater its value. 14 karat gold is less pure, so its value is less per troy ounce, a different function. But the value is still a function of weight. The price increases the more 14 karat gold there is. If we graph the functions represented in the two tables, we can see the difference. The blue line represents one function for 24 karat gold, and the red line is for 14 karat gold. Whether for 24 or 14 karat gold, the total price is a function of weight. For each type of gold, there's just one price for any weight. That's a solid gold return. For wage workers, the number of hours worked determines the amount they get paid. There's a functional relationship between them. This pattern is a function because one quantity depends on the other. If the wage is $7 per hour and you work 1 hour, then you earn $7 before taxes. If you work 2 hours, you earn $14. 3 hours, you'll earn $21, and so on. We can show this function in a table. We can also show the information in a graph. Represent the hours worked along the x-coordinate and the amount paid along the y-coordinate. The variable that influences the other is represented on the x-axis, and the dependent one is on the y-axis. We can associate each point on the graph with a pair of coordinates. The values are the hours worked, x, and dollars earned, y. For example, the first point shown is 1 hour, $7, and the last point shown is 8 hours, $56. Plot the coordinates in the graph to represent the variable's pairs of values. Connect the dots to form a line. The line expresses the increasing pattern of money earned with the hours worked. The line goes up as the hours increase to the right. In this case, the graph of the function is a straight line because the increase in money earned is always the same for the same increase in hours worked. The line also makes a visual pattern, a constant increase over each hour represented. Hard work pays off. Venice, Italy draws a great number of tourists each year, but there's something else creeping into its borders: water. This fabled city of canals may drown if she keeps sinking. That's right, beneath its cobblestone streets are lagoon sediments that constantly and naturally settle. Evidence indicates that over the past 1,000 years, Venice has sunk an average of 7 centimeters a century. That sounds slow, but for a waterfront city, it can mean disaster. And for the past 100 years, it's been sinking at an even faster rate. We can express the relationship between the amount of time and number of centimeters it sinks as a function. A function is the dependence of one quantity on one or more others, expressed as a relationship between variables. An equation can represent a function. Suppose that for the past 1,000 years, the sinking was constant. We can use an equation to represent the sinking from the level in the year 1000 in centimeters as a function of time, like this. The equation helps us calculate the amount Venice has sunk from 1000 until the year 1900, 63 centimeters. But some evidence indicates that Venice began sinking faster, at about 24 centimeters per century after the year 1900. We can represent this with another equation. The equations for how fast Venice sank before and after the year 1900 are similar. But look at how the function changed after the year 1900. By graphing this algebraic expression, we can predict how much Venice will sink in the future if the function remains the same. But for now, ciao.